Okay, so continuing in my series of mini streams, my dog is currently taking a nap, so we'll see how long his nap patience lasts. But after a bit of cleanup, I decided to do something more fun, and instead, I am going to. Now I'm nervous that my audio is going. Yep, audio is going. So now I'm gonna do something more fun. I ordered a couple parts for the alarm clock. One of them is a Sparkfun 7 segment display. This one's not just a simple 7 segment display. It also does. It's got a little Atmel chip or Atmega chip on the back, and they've got some firmware running on there so that it can support a bunch of different serial modes. Like it'll do SPI and I squared C or two-wire interface or UART or it's basically an intelligent one, and I chose it because I wanted something simple. So I also got a 4 by, or what is it? This one's a 2 by 20 display, and I also have a 4 by 20 display. I'll probably get to those two. Haven't, probably not today, but I soldered all my pin headers on, and I also took my Decawave board. I soldered headers on it because I'm going to be connecting something external. So I just put two rows of male headers on there. Did an acceptable job. Although I noticed I got a little solder spike on the back, but. And also because the power isn't brought up, or at least the 5 volt input power isn't brought out on this board. There's actually a test point on the back, so you can kind of see I soldered a fly wire to a test point, and then ran a connector over and used a little bit of super glue to run it through one of the mounting holes, just so I'd have a solid, strain relief there. So just a little bit of super glue, and then a little bit of a baking soda on there to dry it quickly, so now it's kind of a solid piece of plastic there. So I'm going to hope in the next hour, before hopefully my dog wakes up from a nap, I can at least get some characters displaying on this board, and hello world with a 7 segment LED. The idea is to eventually use this as a clock display. I'll see if I like that or if I like this one better, but at least we'll have something, and I can deploy something in my house, and it'll give me some motivation to actually keep something up and running, and then probably very quickly inspire me to write a bootloader so that I don't have to go and flash my devices manually. So let's actually first start by going over to master, and let's just git merge post oxidize. Let's just start from a clean branch, and then git checkout SB POC Sparkfun 7 segment. Sparkfun 7seg. So now I'm in a repo for that. Let's go ahead and just be lazy and go up a directory and cp-r sensor node into my POX, and this is going to be Sparkfun 7seg. So this is just going to be a little proof of concept repo, and then eventually apparently I did something. Apparently this is just going to be a little proof of concept, and then eventually I'll probably try and refactor this out into a embedded HAL driver. So anyone with a serial port or a UART, a SPI port, or a TWIM or I squared C port can use it. Eventually. Today's just going to be hello world and making sure that I understand it, so it's all going to be hard coded to my NRF 52 HAL basically, but it should be pretty quick to refactor out, hopefully. And I think the command structure is the same on all 3 interfaces, so hopefully it's going to be hopefully it'll actually be a really good proof of concept of taking your business logic stuff and then actually 3 different interfaces on there. So actually I think this is going to be a really good showcase driver, but not today because, unless my dog sleeps for like 3 hours. But yeah, let's go. First I need to, in my workspace, update it to let it know that I have a new something in here. So Sparkfun 7seg, that's good. And then I know in my Sparkfun 7seg, I'm going to need to Sparkfun 7seg, and then on all of I shouldn't need any of these, but let's, just for the sake of building, I know that's up 2 levels, so let's cd pox Sparkfun 7seg cargo build. Let's just make sure this still works. Cool. I'm going to end up ripping out essentially everything in this, but why not? Okay, cool. So I've got this. So I'm not going to need any of the radio stuff for now. So let's just start cutting some stuff out. I am going to want the timer, the logger. Don't care about the radio or the reset pin right now. I am probably going to want random. It's just nice to have random. So got my UART. Going to get rid of all of this stuff because it's not needed and not for the sake of you, but I'm probably going to start some music just so I can listen to some music. Make sure it's going on my headphones so I don't get copyright strikes. So let's get rid of this stuff. I don't need any of this address stuff. I actually talked to Hano yesterday, and what I missed and why the address stuff was so complicated is actually because they're just new types that have public fields. So instead of that whole crazy thing that I did with decoding, I literally just could have put a U16 inside of there. So I'll go and clean that up. But today was more about having fun than doing something, doing maintenance. So I've got my 4 items here. I'm not going to need jitter or anything, so let's just clear all of this out, and I'm not going to need my random message stuff. Let's just do resources dot timer dot start with, I don't know, a second, and then resources dot LED red one dot, what is it, dot enable. It's going to tell me I'm wrong. Let's make this a half-second blink. I actually had someone talk to me and they said that they use different blinks to make sure that they get the polarity right, because if you just do it 50-50 like this, then you don't see whether you have it on. So actually, I'm going to do this so it's a little short blink, because if it's a long blink then and a short off, then you know that your polarity is one way, and you know that it's like this. So this is going to have the polarity on for a short amount of time. So cargo build, what do I, fail to resolve, LED red, what do I have? You'd think I'd know by now. Where do I do anything with LEDs? Let's go find a oxidized workspace. I should know this by now. It's my own LED. No, LEDs enable disable. Yeah. No enable type for static mute. Oh, do I need to? That's what it is. It's the magic deref stuff that the. Let's close other tabs. Close without saving. Close without saving. Oh, I bet you I just closed. Yep, I probably just undid all my work. Awesome. But I saved, so it's okay. Main. Okay. Okay. Yeah, enable disable. But what I need to do for both these, I need to deref it first. Pin. Output. Push pill. What do you mean you don't have an enable and a disable method? I hope this doesn't take forever because these should still be the same docs. Hopefully it should only take a little forever. Please use this browser. Yeah, there you go. Pin. What is the GPO pin? Into push pull output. Output. Pin. Output output. Do I need the trait? Is this only? Oh, set low, set high. Set low. See, this is exactly that this is exactly that polarity thing. Nope, not cargo doc. Cargo build. Start. Well, I do need these both to be this, and then because I'm lazy, resources dot, there's a block method, but whatever, dot weight. This is one of those like, oh, I'm doing this because it's the easy way, but it actually ends up being not the easiest way. Let me turn my music down because it is distracting me. Okay, cool. Yeah, I have a bunch of stuff that I don't use, which makes sense. J-Link, so, helps if the device is plugged in. Let me make sure I didn't short something. Hopefully if the stream shuts down, then I shorted something and I soldered and I fried my laptop again. Nope, we're good. Cool, run. Cool, and we've got our little pulse. We know our LED is active low, so we've got a little pulse. Lovely. So actually what I'm going to end up needing is I'm going to need a SPI port. So now that we have our docs, let's go look up spin. Let's figure out what we need to do to make a spin. Okay, so static mutt. It's going to be our spin is going to be a, all this lack of alignment is bothering me. It's going to be a spin. Which one do we want to use? Do we have, I guess we have spin 2. We'll use that for right now. Sure. And it's going to be a late resource, which is all of this stuff. So then the next step is going to be, actually going to be going and figuring out what I need to do for pinouts. So actually, let's go and look at TWM 1001 schematic. I need to figure out what pins I'm going to use for this. No, not the forum. It's on their product page. I know I'm going to need this, and I know I'm going to need the module schematic too. No, that's not going to. Products, DWM module. We're going to read some schematics. So let's first find our dev schematic, and we're going to pick some pins. So this is the Raspberry Pi header, and it's got 3v3. Oh, that's right. Is 3v3 not connected on this either? Yeah, that's right. I forgot that this is a pain to get power out of because the Raspberry Pi header is mostly for the device meant to be a client, if that makes sense. Do I have another header? If not, then I'm gonna have to pause the stream and I'm gonna have to go pull a test point out again, kind of like my 5-volt one. Because I think with the 7-segment display, if you power it at 5 volts, it's going to expect the logic to be at 5 volts, which isn't a tremendous problem, but also isn't great. Do I have 3-volt power pulled out anywhere? This is obnoxious. 3v3 Seger on, well, 3v4, but I honestly don't know if that's connected. VUSB, okay, good. I did pull out the right pin for that. That's test point 11. J2 con. J2. Now I'm looking at connectors. Let's see. J1, J8, J2. J4, you are shorted together, which means either side of that should be acceptable. Because by default, they've got these little solder balls in there that they use instead of jumpers. Park is asking for interesting things. Well, I will have to come back to that. Lumpio is saying, I'm pretty sure the AVR input thresholds are so that they can take 3v3 when they're powered with 5. That is true. I just have to be really careful not to wire up the return path for my spin port, which is fine because I'm not getting any data back. But I'd also like to do this the right way, or at least a reasonably right way. And later I probably will need this. So let me see. I think this J2 is going to be the best place to pull this out. It does mean that I'm going to have to pause the stream and go solder something very quickly. Is there any other better header where I'm going to get 3v3? Because let's full screen this. G8 pin lipo bat. I'm missing even where I saw this before. This 3v4 on VCC is shorted. Yeah, that's going to give me the VCC for that. Okay, well, then I'm going to pause the stream here for 30 seconds. Well, more like a minute or two. And I'm going to go solder a test point in there. Because right now, none of these test points are soldered. So I actually need to go wire up J4 so I can get access to this. So, okay, I'm going to put the stream on hold. And I will be back in 2 minutes when I'm done resoldering my board again. That's kind of obnoxious. Okay, well, I'll be back in 2 minutes as soon as I've soldered two pins. Okay, so like I said, quick little solder job. So now I have a header here. And the other thing that I did is I went and got my multimeter so I can actually make sure that I did this correctly. So let's plug this in. Okay, so I've got power on here and I've got voltage. So what I'm going to do is I'm going to touch my ground lead to the casing of the USB because that tends to be shorted to ground anyway. And then let's check both sides of this. I've got 3.4 volts and 3.4 volts, and let's actually check my 5 volts while I'm here. Oops. You can't see my screen. I don't have a fancy electronics. Yep, and I'm getting 5.12 on the USB, which makes sense because USB is plus or minus 0.25. Okay, cool. So now I have connections. Okay, so now I'm going to find pins. Cool. My dog has started moving. This is going to be a race against time. So I've got my header here. So what do I need? I'm going to need, for SPI, I'm going to need a chip select port, which I probably don't, but I could, because I only have one device, but that's okay. So I'm going to have a chip select. I'm going to have a clock data. That's really it. It's just those 3 pins because it's a single SPI port. And then I'm going to need clock and VCC. Okay, so let's rip off 5 wires. And I just have these like DuPont cables. You can buy them on China for like, or buy them from like eBay or AliExpress for like hundreds of them at a time, and they don't cost that much, which is lovely. Let's actually unplug this first. So I just buy them by the huge amount, and then I'm actually really bad at reusing them. So I have a bunch of them that are just, you know, sheets and sheets and sheets, and then eventually I use the new ones, and then I just, okay, so ground is going to be, so I'm going to pick this ground because it's accessible. So this is the 3rd on the right. I know this is a top-down view. The next one I'm going to connect is power, which is going to come from this header over here. And then what pin should I use? Let's SPI MOSI. Let's just use this one over here because they're already labeled, so it's going to be easier to follow this through the schematics. But so it's not the bottom one, but the 3 above that. This is the exciting part of me connecting cables, and they're not going on. There we go. Okay, so let's see if we follow the same naming convention. MOSI, so this is going to be, this is actually probably just going to say serial data in. So top one is MOSI, so that's going to be serial data in. I am going to connect serial data out, even though it shouldn't be necessary. So the next one is master in, slave out. So that's going to be serial data out. Just in case there might be some advanced modes that do require you to talk about it or talk back to it. So power is going to go into VCC. Let's connect this. Ground is going to go into ground. And the bottom one is clock. So you're going to be SCK. The other one that I forgot is to have a chip select. So let's go ahead and have let's use SPI chip enable 0N. So I need one more wire. So let's pull off one more wire off this bundle. And I'm going to use that second to the bottom one. So those little X's tell me that the bottom one isn't actually connected to anything, which is lovely. But let's put this into the chip select pin. I'm using SPI just because I've been using SPI for the radio so much, so it's fresh in my mind, and I know the code really does work. And I actually sort of want to just, we actually just changed a bunch of stuff, so this is a good chance to change that good chance to test that all stuff we changed actually works. Like I said, eventually I'll also do this does support I2C, which I'll probably use because it uses just less pins and it's easier to put on a bus. These ones let you also like flash them with different addresses so you can share it. But I end up with something like this. So you see I have kind of the matching pins for what my datasheet says, that bundle over on the bottom left, and then the bundle on the bottom right, and then you know what, I'm going to move this ground down to that bottom right one just so the whole bundle's down at the bottom. In case I want to make like a little jig cable for this. And then you can see I kind of have the matching pins there, and I'm using an individual wire. Hopefully no one's yellow-red colorblind because it's just shades of brown and things like that. So this is connected. So step one is plugging it in and making sure that my device still works. Okay, I'm not sending any data to the display, so I'm not expecting anything out there. But let's set this up. I know in the data sheets they did say that the max speed for this was 250K. So interface specifications. So luckily they have all of their stuff as markdown documents, which is much easier to traverse than a PDF. But I'm going to be looking for SPI. So maximum SPI clock is 250 kilohertz with SPI mode 0. So that's what I need. So let us go look at the docs, and we're going to do let spim equals spim new, and we're going to have a we're going to use device dot spim2. We're going to just use one of them. The pins, what do I have pins pulled in as? I probably don't. Yeah, that's fine. We'll just pretend we have it in scope. Spim is going to be a... that's right. We need to go figure out what pins we have. So clock is... Actually, could just totally leave out most of your MISO, but we're not going to. So this is going to be something like, we've already split up the pins, right? So this is going to be pins dot p x x x dot into, let's see, into push pull output dot degrade. So that's going to be something. So that's MOSI is going to be pins dot pxxx into push pull output again, because this is a, and these are both going to be, this is going to be a sum into push pull output dot degrade, and MISO is going to be a sum pins dot pxxx, and I'm just using these as placeholders, into floating input dot degrade, and the degrade is just because you can make a type safe interface because each of these pins actually have their own type, but if you don't want to do that, you can have a driver like this that says, okay, just give me any pin. Okay, so that's my pins interface. The frequency is going to be freak K 250. Let's do 100 for right now. Spin mode 0. Overread character 0. Sure. Let's see. So it's going to be very unhappy about a number of things that I've done here. So I do have spim. So let's pull in some more stuff from spim. We're going to need spim. We're going to need, does it re-export mode? Spim module. Oh, so mode 0, so I need to change that. Frequency as spin freak, and then change that to just mode 0, and then frequency, make sure that this is K, capital K. I can do 125 because yeah, that makes sense. It has to be a multiple of that. And then let's go look at my module schematic. Actually, okay, let's follow back this SPI MOSI. So it's GPIO 10911. GPIO, okay. SPI 1, so it's going to be the SPI 1 MOSI MISO clock. SPI 1 MOSI MISO clock. So these are marked SPI slave, but that's okay. We're going to use it backwards, but we're still going to use the same naming convention, so possibly as confusing as we could have made it. Let's zoom out. Let's see, do they name it? Master in, slave out. Yeah, I guess they do name it there. This is SPI 1. Let's make sure on the module pinout. Where is my module pinout? Do they not give me a module pinout? I don't suppose they do. Well, that's annoying. But let's make sure these vaguely make sense. P18. This is always fun, traversing multiple layers of datasheet. My dog is starting to make grumbling noises, which is not good for our progress. Okay, so SPI 1, that's fine. DW 1000, that's fine. There's not just like a big old module pinout somewhere. It has all of the pins. Ah, Castellation. SPI S. So I guess SPI S. Spiz. SPI S actually show up anywhere else? Nope, just on the Castellation. So I guess I have to assume that the only SPI they talk about, unless it's the one that goes to the, yeah, I don't want the SPI one because that's the one that's actually going to the DW 1000 radio. Ugh. So do you not have the SPI S marked on this? I'm gonna have to go and look at the, do they have SPI S marked on? No, they don't. Okay, so I guess I'm gonna have to look at just the top level one. What are they doing here? Okay, so I'm gonna have to look at this. So J34. Okay, let's go back. Let's look at our, what we got? Chip select, clock, MOSI, MISO. I'm gonna find this immediately somewhere else. But those are the only 4 pins. What, we've got 6 pins and 2 of them are power and ground. So chip select is gonna be J1 dot not 34 3 2 1 30 29 J1 dot 29, and then it just works backwards. So J1 dot 28, J1 dot 27, and J1 dot 26. 34, 33, 32, 31, 30, 29, 28, 27, 26. Okay, so now I need to go find the appropriate J's. So high 20s. J1 dot 29. 29 is P0.03. 28 is pin 0.04, and then J1.27 is going to be pin 0. What is that selection? P0.06, P0.06, and then 26 is 0.07, P0.07. Okay, so now we've got a little table here, and hopefully this should be what we need. So let's copy this back. I do need to remember to have my chip select as well. Although I'm probably just going to set it high in my init and then forget about it, because that should be fine. Or set it low, I suppose. Yeah. So clock is going to be P0.04. And this is going to be, MOSI is going to be 0.06. And then MISO is going to be 0.07. Just checking something real quick. Modulo I2C. Adafruit 7-segment backpack. Maybe. So Simon is saying maybe, but Simon might already have one, but he has an Adafruit one. I don't know if the Adafruit one and the Sparkfun one are the same, but I'll look later. I'm going to keep pushing ahead because my dog keeps making grumbling noises, and I would like to have at least one LED light up before I go on a walk. Save. Could not compile. Yep, you have a lot of stuff. Spim. Oh, right, I need to actually put it in there. Spim equals spim. Into push pull output. Right, you need an initial state. I think you need to be low. Output low, I think. No, what do you need to be? Into push pull level low. Probably don't have this pulled in. Pins spin pins. Cool, so that builds. Alright, let's just blindly start sending it data. Let's see if I can get that, and then I can check my box that I sent data, because my dog is slowly, oh no, he's kind of like, what are you doing down there, buddy? You're just hanging out? That's cool. That's cool. Yeah, okay. So, interface specification, they say just send some data, basic usage. So, if I just write one, 2, AB, so I'm not doing any cursor control, but let's just do a resources dot spim dot. What does my interface look like now? I should know. I rewrote this like a month ago, but to be fair, It's been a very busy month, and I can't even remember what my own code looks like. Come on, buddy. Oh, right. I need to do my chip select too. Let CS equal pins dot P003 into push pull output level. You're going to be high because it's an active grade. Buddy. I don't want you chewing on that. Do you not have a toy that you can chew on instead? Do you not want to chew on this? You definitely don't. You're going to want to go outside. Okay, you got to give me 5 minutes, dude. Static mute chip select is going to be a pin output push pull. One, two, and then CS equals CS. Did I forget a semicolon somewhere? 212. I've seriously confused something. I think I just want right here. Right. So I need right, and then chip select is going to be resources.cs, and I'm probably going to need to do some deref magic here. And then the data that I actually need to send is going to be, hey, but mutt buff. I can't remember if this needs to be in memory or if it's smart enough to do this, so I'm just going to do 0u8. Hey. And then buff.copy from slice. I am down to my last seconds here before he is gonna copy from slice. OX 01, OX 02, OX OA, OX OB. That's fine, so I'm going to copy that in, and that's going to be and buff, and that's going to be result, unknown field, spim. What do you mean? No field spim. All right, I need to include that in the resources. All right. Oh, right. unplug my device to go solder to it. So, let's see. Nope, no light. Womp womp. Let's see, did I do anything majorly dumb? Oh, I'm in a panic handler. Error reading variable. Index out of bound. The length is okay. Let's go into B115. Okay, slices in RAM. Nope. Okay, you know what? Actually, I'm going to use a slightly different method. I think I am... My code might have actually been bad. So let's let buff2 equals 0u8 4. And let's, instead of doing write, let's do transfer split. Actually, transfer. Oh, you missed it this time, but I actually have I have it working. Okay, now he is very upset, or not upset, but he is very angsty to go down and go for a walk. So I'm going to stop the stream here. We have at least Hello World, and then I will come back later today and finish this up. So thanks for watching, and thanks to Kuma for at least being okay for most of that. So I'll be back in a bit.